So, sorry the last video cut off all of a sudden. I'm not sure why that happened, but it did. Another one for the blooper reel. But anyway, we're talking about creatine phosphate supplements, which are used by a lot of people, and the research shows that it can be beneficial for increasing strength and muscle size. When you take a creatine phosphate supplement, the creatine from the supplement goes into the muscle cell, and the muscle cell swells. So you will, when you start taking a creatine phosphate supplement, see an increase in body weight because more water goes into the muscle cell swells, so the muscles get bigger right away. And well-hydrated muscles are better at synthesizing protein. So there actually may be a beneficial effect from creatine phosphate supplements if your goal is to increase the size and strength of muscle. It increases the energy content of muscle for the first bit of power burst activities, and it does cause the muscle to swell, increase in water content, increasing protein synthesis. So phosphocreatine is an energy source itself, plus it helps replenish ATP, improving exercise performance. Now the phosphocreatine and ATP, there's a limited amount that are readily available in muscle. So again, after they're used up, you have to rely on ATP generation from aerobic or anaerobic metabolism. So as far as aerobic metabolism is concerned, it's called aerobic metabolism because it relies on the availability of oxygen. So aerobic metabolism is the creation of ATP from the breakdown of protein, carbohydrates, and fats in the presence of oxygen. It's used to generate ATP for muscle movement as long as adequate oxygen is available. So if you're doing really, really vigorous activity or power burst activity where you don't have time to get oxygen to the muscle, you can't use energy created from aerobic metabolism. Aerobic metabolism is only possible when adequate oxygen is available in the muscle. So this slide shows where carbohydrate, fat, alcohol, and proteins enter aerobic metabolism. Now in aerobic metabolism, protein, carbs, and fats are broken down to a molecule called acetyl-CoA. The acetyl-CoA enters a metabolic cycle called the Krebs cycle. That creates hydrogens, and the hydrogens are then that are created in the Krebs cycle then are passed through this metabolic pathway called the electron transport system, and as the hydrogen is passed from molecule to molecule in the electron transport system, ATP is produced. And at the end of the electron transport system, an oxygen molecule must be available to accept the hydrogen that's been passed from molecule to molecule. You can see that carbon dioxide is created as a waste product in aerobic metabolism. And as far as whereas protein, carbs, and fats enter the process, glucose is converted to a molecule called pyruvate that is then converted to acetyl-CoA that can enter the Krebs cycle to kick off the ATP production process in aerobic metabolism. Fatty acids and alcohol can be broken down to acetyl-CoA to enter this energy pathway. And amino acids from protein can enter this process at various different points to create ATP. And then again, at the bottom you see oxygen is available to accept the hydrogens from the whole process, and water is created. So this metabolic pathway, the Krebs cycle and electron transport system, the enzymes in that metabolic pathway require B vitamins, thiamine, riboflavin, and niacin. So, that's one of the reasons we need the B vitamins for energy production. Now, if you don't have oxygen available for aerobic metabolism, you can create ATP in a different pathway that does not require oxygen. It's called anaerobic metabolism. So in anaerobic metabolism, glucose is converted to pyruvate, and in that process of conversion of glucose to pyruvate, ATP is produced, and then the pyruvate is converted to a lactic acid waste product. Okay, so only glucose can be used for aerobic metabolism. Protein and fat cannot be used for anaerobic metabolism. The lactic acid that builds up is released into the bloodstream, and it actually can be reconverted to pyruvate in the liver, but the buildup of lactic acid in the bloodstream can cause muscle fatigue. That's why one of the reasons you get fatigued faster when you're doing weightlifting or really fast running like sprinting. You get fatigued faster when you're doing anaerobic metabolism. So the lactic acid buildup causes, fatigue, okay? And so anaerobic metabolism can only provide energy for about 30 seconds to 2 minutes of activity. Now, as far as whether you use protein, carbs, or fat for fuel, it depends on the intensity. We just talked about, really vigorous activity or strength building, really intense activity can only use anaerobic because you don't have time to get oxygen to the muscle. So intensity and duration of exercise influences the fuel used, the training level or your conditioning, and the fuels that are available. So glucose is the major fuel for activity. It can be used to generate ATP for both aerobic and anaerobic metabolism. You have glucose readily available in muscle through glycogen reserves. When your stores run out, you hit the wall. You run out of energy because you can't make ATP to sustain movement when glycogen is completely depleted. There are athletes and even endurance athletes who are keto, and they seem to be able to adapt to using fat for fuel better for activity. But this varies from person to person. Some athletes don't adapt as well as others. There's a really interesting YouTube on hitting the wall. I'm going to show, it's a short video clip, so I'm going to show it. This is a marathon runner who's run out of glycogen stores towards the end of the race. In a marathon, about the 20th mile, you'll run out. So you can see the guy standing there. He can't move because he's run out of glycogen. He just can't move. He can't make ATP. So eventually, his liver starts putting out glucose, and maybe some lactic acid is reconverted to pyruvate to create some ATP. And there he goes. He's going to be able to finish. Okay, so back to business. So as far as the intensity of exercise goes, the more vigorous the exercise, the more you rely on glycogen so the faster the glycogen is repleted. If you're exercising to the point where you're out of breath, you can't use, need to go and stop YouTube. I'm going to stop this right now because it's out of control. I'll be back in a second.